welcome to my channel. So today what we are going to discuss in microwave and optical communication laboratory, mode characteristics using reflex Klystron. I mean reflex Klystron mode characteristics. Okay, right. So this is a basic experimental setup, experimental microwave bench setup. Okay, this is what is the name of the device? Klystron power supply, Klystron mount, isolator, variable attenuator, frequency meter, slotted section, detector mount, oscilloscope, and standing wave ratio meter. Right. So now precautions. So bottom of the front panel on Klystron power supply, we have a modulation option. There we have to keep AM option. So we have to select the mode as AM mode. So we have a number of mode. We have to select AM mode. Then only we will get the waveform on the CRO. On CRO's way, we will get the waveform in clear way. Otherwise, we will get somewhat distortion in CRO while we are going to calculate the value of output. Then coming to the next step, HT should be off condition. If you are going to switch it on, here you will get directly 200 voltage. It should be off condition initially. Beam voltage should be initially minimum value. Rippler voltage should be initially maximum value. This meter selection should be voltage mode, current mode, and rippler mode. Whenever we need to vary this option. Okay, right? Now move on to this session. Now we are going to discuss the experimental explanation. So I am going to switch it on this HT. So once we are going to switch it on this HT, here voltage will change from 0 voltage into 200 voltage. Now what is next step? We are going to set up the beam voltage as 210. So 210 I am going to set the 210. I am going to set, yes, I am going to set the voltage as 210 voltage. So 210. So once we set the value as 210 or 215 or 211 or whatever it may be, you have to take the observation in the lab record. So note down the beam voltage and note down the beam current. So when you are going to calculate the beam current, you just change this switch from voltage mode into current mode. If you are going to change the voltage mode into current mode, then you will get the current value as 13 milliamps. Okay, so 13 milliamps beam current. What is the rippler voltage? Rippler voltage should be minus 283 voltage. So this is these three readings you have to note down. So while you are going to calculate the value of mode as well as voltage characteristics using reflex Klystron. Okay, next normal procedure. We are going to minimize the rippler voltage from maximum position to minimum position. Identify the maximum value and the minimum value. I mean starting point, ending point. We are going to identify it with the help of this oscilloscope. So see here, every one of you slowly I am decrementing. I am decrementing the rippler voltage with the help of reflex Klystron power supply. I am decrementing, slowly decrementing. From slowly again I am slowly decrementing. Meanwhile you have to observe the oscilloscope screen. So decrement, do decrement slowly. So you will get approximately 180, 170 between that. You will get the starting point. See here, see is oscilloscope. On oscilloscope we are getting the, see here, where is the starting point? 180. On 180 we are getting starting point. Okay, right? So that you have to note down. Ending point also we have to note down. See ending point, where it is, ending point should be 166. For example, 166 you are getting ending point. This you have to note down value first. From C, so starting point should be what is the value starting point? For example, so starting point should be 175. From 175 to 166, we have to randomly you have to write 175, 174, 173, 172. Like that, you have to do decrement order in your observation in your lab record. So based on that, we are going to identify the power value. What is the maximum for now I set it in the maximum position in Klystron power supply. So based on this particular maximum position, what is the power value? So see here, I am going to remove, just I remove the CRO probe from CRO oscilloscope, right? Then I connected into standing wave ratio meter. With the help of this meter, we are going to calculate the value of power. For maximum point, for starting point, so we are going to identify the power value. If it is over range come, then do decrement. So if you go into decrement, you will get some value. Here you are getting the value 9.30 minus 9.30 or 50 dB. Here the knob is touched with 20. This value and this value we need to add together while we are going to calculate the value of power value. So 20 plus minus 20, here we have a 9, so minus 29.30 decibel power value. So starting point. Like that, we identified maximum point and minimum point. I mean starting point and ending point we identified now up to 166. we need to do 175, 174. For 174, for example, for 174, what is the power? For 175, what is the power? Like that, we need to calculate with the help of standing wave ratio. We are going to calculate the value of power. What is that? From starting point, I mean, in starting end to starting point to ending point, we are going to calculate the value of power as well as frequency. So how we are going to calculate the value of frequency? For example, so see here, maximum point is that I'm going to calculate only one readings. I'm going to calculate with the help of this Klystron power supply. Here we already set to the maximum value 174. So 174, what is the value we are getting the power value? So 20, here we have a 9, minus 9.50. These two values, if you are going to add together, the power value should be minus 29.50, that is the power. Based on this corresponding power, what is the frequency value that we have to identify? This is frequency meter. So you have to rotate this frequency meter in clockwise direction. Okay. Always we are going to get the value in the range of X band range. Okay. So minimum. So we will get the range in between the range of 9 gigahertz range to 12 gigahertz range. We are going to get with the help of this frequency. See here in the frequency meter, we have a red color line. No? So horizontally we have some copper line is there. No, that and all while rotating. See here. So before you are going to calculate this, what is that frequency? Again, I am going to remove this CRO probe from a standing wave ratio meter into what is that? I am going to connect it into oscilloscope. Why? Because while I am rotating, while I am going to calculate the value of frequency, this maximum point should be say reduced into some particular point at certain particular level. This maximum point going to be get reduced. That particular point is nothing but actual frequency for this corresponding starting point of this mode characteristics using reflex Klystron. See here, every one of you, slowly I am rotating. See here, while rotating there is a variation is happened. See the oscilloscope screen. See while rotating, see this is a maximum point, students. See now I am rotate clockwise slowly I am rotating, slowly. See here, there is a variation. Yes, do slowly. There is a variation. Again, signal is again jumping. So where is the clip signal? Where is the clipping operation is happen? At between. See here 9.48. See here we have a copper line. Here also we have a copper line. This red color line should be coincidence with these two lines. So these two copper lines is coincidence with 9.46 to 9.48. Approximately this value should be 9.47 gigahertz. This is nothing but frequency calculation. Okay, like that each and every point 174. Now we calculated a value once at 175. The frequency value is 9.47. At 174 you will get 9.46, 9.45, 9.44. Like that you will get. This is the procedure for calculating the value of mode characteristics using reflex Klystron, or otherwise reflex Klystron mode characteristics. Okay, so like that we have to do beam voltage. We have to set beam voltage. First we set at 210. Suppose for example if you want to set 215, that also we can do it. The procedure are similar. How we are going to calculate the value of what is it? Starting point and ending point with the help of the oscilloscope, and by starting point and ending point what is the power calculation, that is also similar. Okay, for each and every beam voltage setups. Okay, if you have any queries, so please comment please in my YouTube channel. Okay, in bottom of my YouTube channel we have one option, comments. Okay, if you have any queries, please put your message. So for further update in future I will give you more clarity. If you have any questions, please comment, please subscribe my channel. Okay, thank you for watching.